This is a video presentation of Chapter 2, Section 1, Integers. So when we're talking about integers, we're talking about the numbers that appear on a number line. Some books define them as the counting numbers, their opposites, and zero. And that's really a very good definition of integers. It's one that I would find perfectly acceptable on a quiz or a test. So, some definitions here to go with our concept of integers. Opposite, we've already used that word. Opposite, two numbers that are an equal distance from zero on a number line. Two numbers that are an equal distance from zero on a number line. The additive inverse, that's the opposite of a number. So after we find the opposite, that number is the additive inverse. And the additive inverse is the opposite of a number. Integers are the set of whole numbers and their opposites. Again, that definition we used earlier, just tweaked a little bit. They're talking about whole numbers. Well, remember, counting numbers would start at 1. The whole numbers start at 0. Right? So we're talking about whole numbers starting at 0, and then their opposites. Realize 0 has no opposite. It is its own opposite. Right, so integers, again, are the set of whole numbers and their opposites. An absolute value is the distance of a number from 0 on a number line shown by two vertical bars. The distance of a number from 0 on a number line shown by two vertical bars. Okay, so the first question is asking me to graph the integer -7 and its opposite on a number line. So, not a big deal as far as plotting -7 because we see -7 right on the number line. -7 is this dot you see off here to the left on the screen. That's pretty easy. When we're talking about its opposite, remember the definition said that it's the number that's the same number of jumps away as is that number, but in the opposite direction. So -7, when we compare it to 0, is 1, 2, 3, 4, 5, 6, 7 jumps to the left of 0. Its opposite is also going to be 7 jumps away, but it's going to be 7 jumps to the right of 0. So when I make 1, 2, 3, 4, 5, 6, 7 jumps to the right on the number line, as you can see, I end up at +7. So the opposite of -7 has to be +7. So now what they're going to ask us to do, now that we have kind of an idea down of how our number line works, is they're going to ask us to compare the integers. Now let's just think about our positive numbers for a minute to get our senses kind of straight here. When we're talking about positive numbers, I would ask you, where are the bigger numbers? Are they further to the right or are they further to the left? Well, bigger numbers are off to the right. Well, it's still true when I include the negatives. The bigger numbers are still off there to the right, which means, contrarily, that the smaller numbers have to be out here to the left. So what I'm going to be doing here when I'm comparing the two numbers with greater than or less than is I'm going to be saying which number is further to the right. Whichever number is further to the right on the number line is always bigger. Now sometimes that presents a problem for people, especially when we just look at the negatives. Let's say we're just looking at this little chunk out here from -1 to -5. Some people say, well, 1 and 5 is bigger, right? So -5 has to be bigger than -1. No, that's not true. Again, the further to the left you go on the number line, the smaller the number is. So -5 is actually less than -1. Now this first question doesn't really challenge us though, because it compares a positive and a negative. Any positive number is always bigger than any negative number. Doesn't matter what it is, a positive is always bigger than a negative. So when I'm comparing 4 and -4, which you can see they've already plotted on the number line, 4 has to be bigger. And indeed, it's further off to the right on the number line. So we're going to say here that 4 is bigger than -4. Now when I'm comparing -15 and -9, Now I'm actually comparing two negatives, so now I might have to think about this. But again, we know that the number that's further to the right on the number line is always bigger. Well, when we see these two plotted, we see that -9 is further to the right on the number line. So that's got to be the bigger number. So -9 compares to -15. Well, the way this is written, this has got to fill in with less than. -15 is less than -9. If you have problems with your greater and less than, remember, just like elementary school, the alligator always eats the bigger number. All right, and indeed, he's eating the -9 there. -15 is less than -9. What they're pointing out in the directions there is the exact opposite of the way we've been saying it. They're saying with -15 being further to the left, this one being further to the left, this is the smaller number because, again, smaller numbers on your number line are always off to the left. So now what they're going to have us do is they're going to plot all these numbers on a number line, and we're going to put them in order from least to greatest. Now, plotting them on the number line is not really much of a chore because all those numbers appear directly on the number line. All right, really the chore here is the least to greatest part, and again, what we have to remember is that our smallest numbers on this number line are always off here to the left, and our biggest numbers are off here to the right. The other thing we would want to be careful about in a question like this is simply the directions. Are we reading the directions carefully? Notice that this question says least to greatest, so there's probably nothing unexpected here. But there's nothing to say that they couldn't say greatest to least. So if we say greatest to least, remember, since the biggest numbers are off to the right, we're going to list the numbers on the right first and then head back towards the left. So we plot -3, and we put its dot on the number line. And then we plot 6, and we put its dot on the number line. We put a dot on -5, and then we put a dot on 2, and then we put a dot on 0, and we conclude by graphing -8 by placing a dot on top of -8. Now that we've graphed the points, in order from least to greatest is the order the points appear from left to right. So since the first dot we see is on -8, -8 is the smallest. Then -5, and then -3, and then 0, and then 2, and then until we get all the way up to the biggest number, which is 6, which is the exact order you see down here in answering question number 3. Now in number 4, they're talking about something a little bit different than us just ordering numbers. They're talking about absolute value. Absolute value is the distance a number is from 0 on the number line. How many jumps away that number is from 0 on the number line. Pretend, might make you giggle a little bit, let's say I put a rabbit on my number line, and I said to the rabbit, start hopping. And he decides he's going to hop to the left. And then I put him back at 0 and I say, okay, hop, rabbit. And this time he decides to hop towards the right. Either way he goes, let's say he goes left 2 and then he goes right 2. He still makes 2 jumps either direction. Notice I never said 2 and -2. He just makes 2 jumps either direction. Yeah, one time it's 2 jumps to the left, the other times it's 2 jumps to the right, but it's still 2 jumps in either direction. That's what absolute value is. Absolute value is the number of jumps it would take to reach 0 from a given number, or the opposite direction from 0 to a given number. Because it's a distance, it's always positive. Whether I put the car in drive or whether I put the car in reverse to go from Westville to Valparaiso, I'm still covering a positive amount of distance. I'd be doing it a little bit strangely if I do it in reverse the whole way, but it's still a positive amount of distance. That's what absolute value is. It's a distance, and it's always a positive amount. So in the A question, they're asking me to find the absolute value of 8. Now again, those 2 vertical bars, as we saw in the definitions, mean absolute value. So again, that is really just a fancy way of saying the absolute value of 8. The mathematically correct way of saying the absolute value of 8. So what I'm going to do is count off how many jumps it takes me to get from 0 to 8 on the number line. Well, as I start counting here, I see that it's 1, 2, 3, 4, 5, 6, 7, 8 jumps to get from 0 to 8 on the number line. Since it takes me 8 jumps, the absolute value of 8 is 8. Done. Now we'll do the same thing with the B question, which is the absolute value of negative 12. So I'm going to count how many jumps it takes me to get from 0 to negative 12 on my number line. And as I count this one off, I see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 jumps to the left to get to negative 12. So the absolute value of negative 12 is 12. Now some people look at that B example and say, well, the answer is just always the opposite. And they're very, very wrong. Because look at the A example. We said when the absolute value of 8 was figured out, the answer was 8. So I started with a positive, I got a positive answer. But then when I started off with a negative question, like in B, negative 12, notice the answer was also positive. Positive gives me a positive, negative gives me a positive. Absolute value is always the positive value distance. How many jumps a number is away from 0. Again, it's always positive. The result, the answer, is always positive. Don't ever say that it's the opposite, because it's not the opposite. It's always the positive valued result. Okay, so let's conclude Chapter 2, Section 1 with the check it out examples here. Here, we're asked to graph the integer 5 and its opposite on the number line. So 5 is pretty easy to plot because it appears directly on my number line. I put the dot on top of 5. And again, when we're talking about the opposite, it's the same number of jumps away from 0, but in the opposite direction. So to get to 5, I have to make 5 jumps to the right to get there from 0. So when I counted off 5 jumps to the left, that's going to be its opposite. And as you can see, I did that, and I got negative 5. Now in the second one, they're asking me to compare the integers using less than or greater than. Remember, when we're talking about negatives on a number line, or even any number line, even if it includes the positives, when I'm talking about numbers on a number line, the smallest numbers are always off to the left. And the biggest numbers, of the larger numbers, are always off to the right. So when I'm comparing negative 7 and negative 10, I see that negative 10 is further to the left. So it's the smaller number. Negative 7 being further to the right on the rough number line I just drew is further to the right. Bigger numbers are to the right. And remember, the alligator always eats the biggest number. So in this case, when we compare the two, we're going to say that negative 7 is bigger than negative 10.